you very much. Right. Well, we're a tiny, tiny bit behind time, but that's only because we started 10 minutes late. And I'm obviously in desperate trouble with Roger for allowing it to go late, but I was trying to explain that this is San Diego, and we're very relaxed and kind of, yeah. So I hope that's okay. So if we get our speakers up on stage, can you want to sit up on stage? And we'll just answer a few questions that are burning to you. We have a couple of roaming mics, do we? And why don't I take a couple of questions while we're assembling people, and I'll try and remember them, and then I'll be able to speak them back, and so on. So the gentleman in the black, why don't you ask the question of me, and then I will deal with it once we've got all our speakers here. Yes. Right. Okay, got that one. Another one? Gentleman in the white.
Yes. I found it interesting with Neven's presentation. I've thought about this a long time myself, the difference between pleasure and pain. It occurs to me, and I'd like you to comment, that it's somewhat like dissonance. In other words, pain. And pleasure is more like consonance. It's almost
okay.
like...
So a musical analogy.
Like a musical analogy, indeed.
Okay. And one more question I'll stack up, and then I'll start divvying them out. So musical analogy. Gentlemen, yeah? Yeah?
Yeah, this is a question for Dr. Penrose. Do you think that the laws of the universe is the consciousness or awareness of the universe, taking the fact that every space and time, moment of time in universe is aware of these laws?
Itself? No. I mean, the universe as a whole, not in my opinion, I mean, you could imagine such a thing, but in my opinion, consciousness comes about when the proto-consciousness is organized, orchestrated in a way, in relation to the first question, which I don't have any clear idea about, I'm afraid. So I don't think the universe as a whole is conscious. It would need to...
Can I repeat the question?
Sorry? Oh, I see. The question's changed.
My question is that since the universe is aware of the laws, every moment of time and space knows the laws of conservation are to be true, does that mean its awareness, let's forget the consciousness, is the universe aware of its laws constitute the awareness of the universe?
Not in my terminology. I mean, the universe as a whole is not, in my view, aware of anything. It's not, that's, aware is just an aspect of consciousness, in my view. I mean, it's not the whole of consciousness, but it's some aspect of it. So, no, I mean, it would have to, the view is that you have to have this reduction, spontaneous reduction, and the spontaneous reduction is just an element of proto-consciousness. It's not the universe as a whole, it happens in certain places. So I can't see that the answer to the question is yes, in my view.
So the second question was about basically to what extent is pleasure and pain similar to music or some sort of thing like that. So why don't I give that to Hartmut, and then you can...
Yeah, I felt I went already out on a limb proposing that relaxing to a stable state feels pleasant and going to an excited state is unpleasant. It just struck me that this fits together with a number of observations or logical constraints. Sort of pushing it beyond this, it would be, I don't know, maybe somebody comes up with sort of a measurement protocol, how we could assess. I mean, obviously it cannot be such a subtle phenomenon in the human nervous system, and there's of course all sorts of studies what happens when you eat a cookie, but sort of breaking it down to at what are the systems that really correlate with a pleasant sensation, that we're still far from that.
I think pleasure is a learning signal. It's created whenever you feel a need, and it's proportional to the amount of need fulfillment that you do per unit of time. With respect to music, the pleasure that's generated from music has many possible dimensions. One of them is aesthetic. You have a certain structure discovery that possibly piggybacks on some of the functionality that we have for learning language. Then there are physiological parameters that might be elicited by music, that you entrain your physiological rhythms and your brain patterns with the music, which in itself can be intrinsically pleasant. Then there are social connotations that go with music, narrative connotation and so on. They can fulfill many, many different needs, and this means that music can be intrinsically pleasant if you are susceptible to one of those needs.
This question is regarding neural networks. So we have been talking about deep neural networks. So as we understand that it is a basic computing unit, and we also talked in morning about microtubules. So can microtubules be considered as basic computing unit, which can which can, the quantum effect can be implemented using it? And the third part is that when we talk about the concepts, biologically these are electrical spikes. How do concepts translate to these electrical spikes?
So I think the question is a neuron a computing unit? And how does a neuron represent concepts?
That's right.
Gosh, is there anyone else up here who'd like to answer that question? We don't have any neurologists up here, remember? Who would like to? Joscha, come on, you can do that one.
I don't think that concepts are represented by individual neurons. They are represented by ensembles of neurons. And I suspect, and it is not a thing that is completely consensus yet, because there are a multitude of theories on how that works, that concepts form a map that is something like the address space of your sensory motor scripts, of the things that produce your mental representations. And concepts are synchronized between speakers through language, which is why we can use statistical analysis of language to do machine translation. These machine translations work only on conceptual structures, nothing below this. They cannot imagine what the concept means. The concept is basically what anchors different linguistic symbols that are synonyms on some part of a landscape. And this landscape is a map that is produced and held stable by a multitude of different neurons that are working together and forming circuits and oscillators. Does this answer your question?
Excellent. Middle back there.
I have another question for you. So in your model, what do you think the difference between consciousness and self-consciousness, or let's say self-awareness in your model? What's the
difference between awareness? So who are you asking the question to?
I don't remember, but the middle...
Joscha, right,
Joscha,
okay.
Yeah, thanks.
So is self-awareness the same as awareness of other things?
Yeah, let's say do you have the awareness or consciousness about pain, and the awareness that you are the one that has this pain, no? So,
okay.
I think when you meditate, you can discover that your awareness of yourself can be redirected on the awareness of something else. So for instance, you might identify as a perspective being with the universe itself if you lose the connection or dissociate it to your self-concept. Which means to identify, for instance, as a human being or as a social person or as somebody who wants something and so on is somewhat arbitrary. It's a trick that the mind uses to make a particular kind of model and regulate that model. And you can change that model into becoming aware of that you are the universe. And you have the illusion that there's a cosmic consciousness because suddenly your representation of the universe gets unified with what you think is your perspectivity on it. But this is a mental state. There is a difference between this perspective self and the awareness of having a consciousness, of having conscious access. And the awareness of consciousness doesn't need to have content. It's the awareness of the fact that or a model of the fact that there is a process that accesses your own models.
The question was is self-awareness the same as awareness of the world? Did I have that right? I mean, the same kind of thing, I would say. But self-aware, I mean, I'm just going to make a stupid, obvious comment. Self-awareness is awareness of oneself. And awareness of the world is awareness of the world. They're just different. The awareness is the same, but they're different things it's aware of.
Yep. I'll give that to you. So next question. Do we have one for Hartmut? Hartmut? Okay.
I was confused by your observation 3, where you said that it would be worthwhile to replace the top layers of a neural network with a quantum computer. I would have expected the exact opposite. For example, when we do transfer learning, we remove the top layers of a neural network and replace it with an SVM, for example. Okay? So why is my intuition wrong? Why wouldn't it be that you would want the quantum computer to discover better features, for example?
For example, if we were to find, let's say what we have done like little numerical tests for simulated quantum neural networks. And then we found, for example, that we could learn something like subset parity to a much larger number of inputs than a classical neural net. Essentially, the classical neural net would have to be larger to do the same thing. It would have more parameters, and therefore it takes a longer time to learn. So if you were to find, let's say, a mapping from 50 input units to just 1 output unit for certain types of learning tasks works much better on a quantum neural network. For better meaning, for example, lower sample complexity, you need less training samples, then you can easily use this in a much bigger context by letting the lower level tasks, such as feature extraction, be done by the early layers of your neural network. I'm not saying this is the only way to do it, but this would be a very straightforward way. Let's say often deep neural networks, even though they might have thousands of output units, they are often, if you use something like logistic regression, essentially each output neuron fights for itself, and there are sort of these funnels that end in single neurons on the output layer. So it's just a very straightforward way to use a quantum neural network here and now, as soon as we discover, even on a 50 input quantum neural net, some advantages.
Okay, so your observation was basically about efficiency and speed rather than better features, right? That particular observation.
Yeah, in the moment I'm just after efficiency and speed, yeah.
Okay, thank you. Another question for Roger, maybe? Okay, gentleman on the blue, one in from the green, and then maybe you can negotiate between you as to whether you've got the same question or a different question.
Okay. My question was for Roger. Roger, I don't understand what your post-collapse wave function looks like. If you look at the spontaneous collapse theories developed by Philip Pearl and Girardi, Remedi and Weber and so forth, if you have a particle which initially starts out, it's confined to one dimension of space, and it initially starts out in a superposition of 2 Gaussians, where those Gaussians are located in separate places along the dimension of space, then the post-collapse wave function is still a superposition of 2 Gaussians. One is just raised and the other is lowered. And there are technical reasons for why they have to settle for this. But what it means is that the post-collapse wave function is still always a superposition. In the literature, that's called the tails problem. So I'm wondering what the post-collapse wave function looks like on your theory, because it looks to me that if your post-collapse wave functions also have tails, then you can never remove superpositions of space-time curvature.
I don't think I understood the question. I mean, you have these ideas of Jacek Aharonov involve pre-selection and post-selection, and you can get cases where you have rather extraordinary things happening. Well, they very rarely occur, but they seem to be rather strange. I'm not sure if that's what you're talking about, and I didn't quite see, I'm afraid I didn't understand the point at the end.
Okay, so I know you, and I know your physics is fairly thorough, so that's a discussion over a cup of coffee. Thank you very much for that one. So, gentleman in the green in the middle. Oh, sorry. We've got a man with the...
This is a question partly for Roger and partly for everyone else, and I'll set it in context. The question is very simple. Why do you assume that there is only classical physics and quantum physics, and everything you have to do with computation, computationalism, or any other computer calculations you're using is only going to be looking at quantum theory and quantum models? That's the question. Now I set it in context. In the human physiology, everything happens from criticality. Everything in human regulation, which ultimately means the human mind, happens from complexity. And complexity means instability, and the physics of instability, which is critical instabilities, has nothing to do with either classical physics or quantum physics. So why do you limit yourselves to quantum physics?
Well, I'm going to answer a little bit of that question.
Was that a question?
Okay. So I think that what you're saying is that people on the panel, including me, are only talking about classical or quantum physics, and I think that that's wrong. I think what Roger is saying is that classical and quantum physics are insufficient, right? That something appears to be going on in our heads that would require a modification to quantum physics as we know at the moment, which is not quantum physics as we know at the moment. So we're trying to add an additional feature.
Yeah, I sort of agree. Yes, I mean, the view I have is that classical physics and quantum physics are both approximations to something that we don't know yet. We get some idea of what it's like, but we need to have a better theory than either one or the other. It's true that in many circumstances you can treat it according to quantum physics or according to classical physics, because the other part doesn't play much of a role. But yes, there's something more, as James was just saying, and the something more would have as limiting cases our current view of quantum mechanics or our current view of classical general relativity. And so one has a more inclusive theory. It's not that you have one or the other. You have the bigger theory, which may specialize in some circumstances to look like quantum physics, or in other circumstances to look like classical physics.
I think the other two, it'd be interesting to see what
I think that it's a very interesting division between us. It's completely correct to say that you are trying to go beyond current physics. You try to make an extension to physics, which is very bold because we don't have data in the particular area. It's more conceptual. We don't know what that is going to be yet. Physics at the moment assumes that the world is made from quantum fields that evolve to some kind of Hamiltonian, or another mathematical formalism that comes down to something that is mathematically equivalent but written down in a different way. And it could be that we change that, but we don't know about this. And for us, the question is what kind of computation is facilitated in this universe or outside of this universe, and what kind of computation do we need to build the equivalent of minds? Roger thinks we need computation that goes beyond the computation that is known in physics. I think the classical computation is probably sufficient. You think that classical computation is probably sufficient, but it's going to be much faster with quantum computation, right?
Why don't you hand the microphone to Hartmut and he can answer that question.
Yes, so maybe first I want to make a bit of an upbeat observation, in the sense that what we observe is that quantum information has given fields of physics that previously were not talking to each other much a common language. So suddenly people who wonder about the information paradox of black holes and wonder what happens if you throw a qubit into a black hole which is entangled with another qubit that's outside of the event horizon, or condensed matter physicists or quantum biology folks, they can all look at each other's equations now and understand to some degree what the other is doing. So I think that bodes very well for the next 10 years, seeing interesting fusions of areas of physics. But of course the fundamental part of your question is more, this may be a bad excuse, but we just take baby steps. Quantum physics is what I have now, what I somewhat understand, and we can build machines based on this theory. I'm not by any means saying this is the end of it, and I'm, of course, a history of science would suggest that in probably 50 years we will talk about maybe David Deutsch's new constructor theory or completely other forms of physical theory. I don't know, but it's likely.
Gentleman in the hat, who's obviously got a burning question.
Final comment.
Hello.
Instability physics is completely non-computational.
Okay, thank you. Gentleman in the hat.
Hi. I know that most of us here and most of the discussion around artificial intelligence, seeing as we are human beings, the model that we have in mind, the Holy Grail, is to replicate the human mind. But seeing as there are so many different forms of intelligence on this planet, is there a benefit to the development of artificial intelligence looking at non-human forms of animal problem solving and other forms of intelligence?
So this would be squirrels and crows and dolphins and other
ants
things.
And bees. And are there situations where non-human forms of intelligence may be able to complete tasks better than a human-based AI?
You got the microphone?
The main form of artificial intelligence will not be robots that are existing on the same level of us. The main form of AI will be organizations. It will be corporations, nation states, universities, whatever needs compute to make sense of what it's doing. And we will be living inside of AI largely, not next to it. It's not going to be robots that compete with us for resources. It's going to be stuff where we are going to be mostly the microbiome. Of course, there's also going to be intelligent artifacts, but it makes probably more sense to imagine robots as the extremities of future AI. In this sense, we should not expect AI to be very similar to human AI. Personally, I'm interested in building humanoid AI because I want to understand how we work. And I'm also interested for the same reason in animal-like AI, because I'm interested in how minds work in general. But in practice, if we are able to build sentient machines, they are going to be organizational things, mostly.
And Roger, we've talked about whether squirrels or dogs were conscious or intelligent, you know.
Yes, well, I think the way I look at this question is that the reason that AI seems to be trying to, well, compete is perhaps the wrong word, with human intelligence is because that's what it's trying to do. I mean, it's trying to play chess or Go or whatever it happens to be, or do things that human beings do, and maybe sometimes try to do them better than humans do it. And we're not so interested in trying to do machines that do things better than squirrels. But I don't see why you shouldn't study that. It's just, you wouldn't get so much money, I suppose, for studying AI for squirrels. But it seems to me it's just this is the way it's driving, and that's why AI is aimed. I don't think it's at all like what humans, the way we think or what we do. I think what we think and what we do is much more like what squirrels do than what AI does. But that isn't perhaps the question.
And Hartmut, when your quantum AI machines or your quantum computing machines grow up and they become very powerful, will they look anything like a human being or a squirrel or a dog or nothing like them?
First of this question, actually, when I wrote my PhD on autonomous mobile robots, the strategies we use to have them navigate through our institute and find back, let's say, there's a power station that was very much modeled after how ants or rats navigate, or simpler systems, simpler animals. That was very fashionable at the time, and I'm still a big fan of looking sort of at, I think, for example, the intelligence of a single cell is way underappreciated. I think if you look in evolutionary periods, I think a single cell is probably the most optimized machinery, and I would like us to think more what amazing feats, or what it would take to replicate the amazing feats of a single cell. Big fan of this. In terms of quantum AI, I think I made in my talks as a case that I'm convinced that the I think creativity can be well described by, or formalized by, finding a low point in an objective landscape that expresses an optimization landscape. And quantum enhanced optimization will be better in finding those low-lying minima, and hence will be the most creative system we know to build to date. So I have no doubt about that.
One important point is maybe think about the difference between a dog and a human. What is that difference between a dog mind and a human mind? One of the obvious differences is given by the affordances of the dog. The dog doesn't have hands. It smells, has much better smell than humans. And this means that the world presents itself very different to a dog. The next thing, a dog has different needs. The social needs and the cognitive needs of a dog are very different. As a result, it's going to pay attention to very different things, and it means it learns very different things, because you only learn things that give you reward signals, and you only pay attention to those things that capture your attention because you have a need that is related to them. And then the largest and maybe most important difference is that our development is much, much slower, and our brain is slightly larger than the one of a dog, which means during our adolescence, during the training phase of our brain, we see vastly more training data than the dog's brain. So we get to much better abstraction than a dog can possibly get to.
Thank you. So, unless, do you have one more last thing to say on that point? No.
Me?
Well, I think we're at time. So is there one more burning question out there that someone feels must be asked or answered today? A really bad, the gentleman right at the back there that hasn't spoken so far.
I have a question for Janosch, and I'm wondering if he feels a current modern digital computer could ever become conscious running a software program.
Oh, well, that's the topic, isn't it?
And if not, what hardware would be required to make a computer conscious?
What hardware would we need, well, to make a computer conscious? So Roger Penrose would say...
Well, you need to take advantage of the quantum state reduction. I mean, this is it's not a question of using artificial intelligence in the way we use it now. You need to have something which harnessed, I mean, it was in relation to, I think it was the first or the second question, which I didn't have a clear answer to. Namely, you would have to, on my view, have a way of taking advantage of what's going on in quantum state reduction. See, at the moment, it's very hard even to see the effect at all in an experiment. So we're way off it. But without doing that, in my view, we don't have consciousness at all. So in my view, none of the devices, artificially intelligent devices, computer-driven devices, have any consciousness at all. Unlike us, something is going on in our brains which involves, on the view I hold, the reduction of the quantum state, and that being correlated, orchestrated over large areas of the brain, and that would, on this view, enact consciousness. But we're so far off doing that at the moment. We don't even know from physical experiments that this process that I'm talking about actually exists. We know that something must happen in the reduction of the quantum state, but we don't know exactly what's happening.
And Joscha, do you think a computer could just do it? You
Yes.
only got like a one-sentence answer here.
Roughly a year ago, I taught a class at MIT about the future of AI, and I took a small survey in that class on what kind of hardware do we need to build a mind that is capable of human performance and consciousness and so on. I think most of us felt that consciousness is going to be naturally emerging as soon as the system starts to model its own attention properly. And the capacity for doing that, the majority of the class was quite optimistic. We thought we can probably run a person on 200 gigabytes if we only knew how. We don't know how. We are pretty optimistic with respect to this, but we have some reason to believe that these numbers might already be sufficient. We had a couple students that thought we need petabytes, and we had one student that we thought we need exabytes, but they were the outliers.
So, Roger, a quantum gravity computer. Joscha, a big enough computer. And I think, are you undecided at the moment? I think.
No, but you're asking the wrong person. Personally, my view on this is more the panpsychist view, is that essentially I think consciousness is associated with the elementals of physics, and we should more think about it like mass or spin or possibly state reduction, as Roger suggests. In that sense, consciousness pervasive. It's already in a grain of salt or sand, I would say. There is some proto-conscious present.
So, sort of the wrong question. You don't know machine would do it. The universe sort of kind of is.
May I just make a slight objection to the term quantum gravity computer?
Yes, of course.
Because first of all, it's not quantum gravity, because the term quantum gravity means the correct application of the application of what we regard as current quantum mechanics to gravitation theory, whereas this is almost the opposite. It's gravitational quantum mechanics. I don't know how you say that.
I shouldn't have
sorry.
baited you in that way.
There should be a good term for it.
Yeah, we need a good term for a relativistic quantum computer or a modified quantum computer.
Think about it.
Thank you, everybody. That's the end.